Hello, my name is Bob Bernich. I'm software development engineer with Microsoft SQL Server Integration Services team. In this video, I'm going to talk about the SSIS data flow internals and in particular about lifetime of memory buffers used to transfer data through data flow graphs. This presentation is part of the video series titled SSIS Designing and Tuning for Performance. Please make sure to also check other presentations from this series as listed here. Alright, let's get started. In this video, you should learn some interesting details about the implementation of SSIS data flow engine. The most of this presentation will be a live demonstration to show how the data flow graphs get divided into execution paths and how buffers carry data along those paths. At the end, we'll briefly show a list of design guidelines to help you in the process of building and maintaining SSIS data flows. Now, let's switch to some real action and show how the data flow buffers fly. As you can see, I prepared a simple package to demonstrate some interesting things happening in the data flow execution engine. It has a flat file source with very simple file. IDs go from 1 to 20 and names from 1 to 10 and then repeated. Character map uppercases the name column. The derive column adds additional 2 output columns with simple operations. Second one is interesting with this casting I'm using to change the column size so I can control how many rows will be in each buffer. Multicast just shares this data in 2 branches. One of them have the derive column to add star to existing name column. The other one is very similar. It only adds 2 stars. Sort component sorts data by the name column. And this character map lowercases the name back. Right, let's execute this. Here's the first buffer coming out of flat file source. I intentionally made this buffer contain only 10 rows by tweaking the column size and some other parameters. The second one comes out of flat file source. And then we see what comes out of the sort component, have all the 20 rows and the data is sorted by the name column. Now let's switch to some special educational application I built to better show what's happening during the data flow executions. Let's open the same package we just saw, package 1. You can probably recognize the data flow graph even though it's laid out differently. Now let's go step by step and demonstrate what data flow engine does with this graph. In this step, the scheduler analyzes the graph. It identifies the execution trees, parts of the graphs that operate on the same type of buffers. Those are marked with different shades of green color. Dashed lines divide outputs, producing buffers and putting them into queues to be processed by downstream paths, like this. The sort component also has a special treatment here, as it is an asynchronous component, meaning it consumes one type of the buffer and produces a new buffer on its output. It is also a blocking component, meaning it will need all the buffers coming from upstream to produce its first output buffer. Let's see what happens in the next step. Now the buffers are finally getting defined. We'll have one buffer per execution tree. The columns in the buffers are defined by walking the execution trees and collecting all the output columns defined by the components of that tree. So if you look at this buffer, we see the first 2 columns are defined by flat file source, The next two are defined by this derived column. The last two columns are somewhat specific. There will be copies of the name column, so that will allow these two derived columns to do in-place operation on the name in parallel in these two branches of multicast. The other buffer is simpler. It contains only the pass-through columns of the sort component. So now, once the buffers are defined, we could start running this data flow. Now we are at the point when the first buffer got produced by the flat file source. You can see only the first two columns are populated. The rest of the columns will be calculated downstream. Let's continue this execution. The same buffer passed the character map, and you can see the name column is uppercase now. Now you see the second buffer comes after the flat file source, and that means we have parallel execution in the same execution tree. The buffers get pumped by the source and also processed by downstream paths. The first buffer passed the derived column, additional two columns are added. The second one passed character map, name is uppercase. You see two buffers are flowing to the same execution tree. It means we have concurrent processing of this data. The first buffer is now in the first multicast branch, and at this point the name column got copied into its name star placeholder, so it will be consumed by the derived column and also changed in place. The same buffer is processed in parallel in the other branch of multicast, and the name column is copied into another placeholder too. Now the second buffer passed the derived column. These columns are added now. The first buffer is now processed by the derived column, and you can see star is added to these names. The same thing happens in the other branch. Only two stars are added by this derived column. Now the second buffer enters the first multicast branch, and you can see the name column copied. Now the second buffer is in the other branch of multicast. The other name column got populated. At this moment, the second buffer passed the first derived column, and the star is added here. And now both of the buffers are at the input of the sort component, and that means the sort is now ready to produce its first buffer. As we know, only two buffers are going to flow through our system. Okay, now the sort produced its first buffer. You can see the name column is sorted. And after the final character map, we see the name is now lowercase. So this ends this demonstration of how buffers flow through data flows. At this moment, we are going to switch back to the slides to do a brief recapitulation. Here's some tips we could derive from the previous demonstration. You should always try to keep your buffers in memory. Estimate how much memory will be required by data flow by knowing the size of your data set and the column metadata used to define buffers. Hopefully, the demonstration you just saw would help in that. By knowing your target system, you could do additional tweaking of the data flows to make sure they run with enough processing and memory power. You cannot benefit from too much parallelism in the graph if there are not enough CPUs to support that. If you have blocking components, make sure all the buffers processed by those components could fit into available memory. For obvious reasons, try to avoid blocking components for large data sets by either doing those operations in your source system or partitioning processed data into smaller buckets. Also, make sure you always double-check if you can simplify your logic to avoid some of the blocking components. For example, in some instances, source followed by merge joins can be replaced by simple lookups. This is the end of this presentation. I have to thank Thomas Kaiser for his contribution to this series. Also, thank you to Carla and Douglas for letting us do these videos and their great feedback. Please make sure to check top 10 SSIS best practices from SQLcat.com site as reference here. Thank you all very much for your attention, and we hope this will be of value to you when designing your future SSIS packages. Again, make sure to watch other parts of this series and send us your feedback. Thank you.